Hello everyone, I welcome you all to the Autonomous Academy. Here I am going to do the analysis of a question paper of M.Sc second semester of subject Electronic Devices of the year 2019. Before starting this analysis, I would like to brief you about the pattern of the question paper. This question paper contains two sections, section A consisting of short answer type question and section B consisting of long answer type question. Section A is having 15 marks and section B is having 25 marks. So in total we have 40 marks on the distribution of question paper of electronic devices. Now let us begin our discussion with the analysis of the short answer type question. The first question that we have is discuss the microwave devices. Any device that is capable of generating, modifying, amplifying, detecting and measuring microwaves or voltages having microwave frequencies are known as the microwave devices. So the microwave device can be any device, but it should have the characteristics of generating, modifying and amplifying the microwave or microwave frequencies. If a device is having all such characteristics, then we will see that this device is known as the microwave devices. Next question is discuss the construction of tunnel diode. So let's try to understand first the tunnel diode and then we will move on to the construction of tunnel diode. Tunnel diode is a highly conductive and heavily doped p-n junction diode in which the current flows due to the tunneling mechanism. Here question arises, what is the tunneling mechanism? So the tunneling is the phenomenon of conduction of electricity, conduction of current in the semiconductor material when the charge carriers are punches through the barrier instead of climbing it through the barrier. That means in tunneling process the charge carrier do not climb through the barrier but they punches through the barrier. So such a mechanism of conduction of current is known as a tunneling mechanism. Just because of the heavy doping, tunnel diode can be used in forward bias condition as well as in the reverse bias condition. Tunnel diode is a fast switching device and for this reason it can be used in amplifiers and in high frequency applications. Now let's come to the point, construction of the tunnel diode. So for the tunnel diode, for manufacturing tunnel diode we can use gallium arsenide and germanium material. And this tunnel diode can be made up of or can be consisted of the two electrodes, namely anode and the cathode. Here p-type semiconductor material acts as anode and the n-type semiconductor material acts as cathode. We cannot use silicon for the fabrication of the tunnel diode. It is because the ratio of the peak value of the forward current to the value of the valley current is small in case of silicon while it is greater in case of germanium. So just for this small ratio in case of silicon, we cannot use silicon for the fabrication of the tunnel diode. So this was all about the construction of the tunnel diode. Moving on to the next question. The next question is write short note on memory. So as we all are familiar that memory is the internal storage area in the computer system. Memory can be used as a shorthand notation for the physical memory, which refers to the chips that is capable of holding the data. If the computer is having the memory of 1 megabyte, then we can say that computer has a capability that it can store 1 million bytes or characters of information. Memories have a classification like RAM, random access memory, ROM, read-only memory, PROM, programmable read-only memory, EPROM, erasable programmable read-only memory, and the last one is EEPROM, electrically erasable programmable read-only memory. So this is about the memory. Next is draw and make truth table for AND or not an exclusive OR gate. So here we have asked the question about truth table. So what is truth table? Truth table is a good way to show the function of the logic gate, and here we have asked the function of a AND gate or not an exclusive OR gate. So let's try to understand them one by one. AND gate. AND gate is a logic gate which can have two inputs and one output, and in AND gate the output is true only when both the inputs are true. That means if both the inputs, let's say A and B, are having the value 1 1, then the output value will be 1. Otherwise the value of the output in AND gate will be 0. Next is OR gate. OR gate is a logic gate with two inputs and one output, and here the value of the output in OR gate is true or 1 if at least one of the input value is 1. That means if A and B are two inputs, then inputs, and the value of A and B is such that one is having in one situation the two inputs are having value 1 0, and in second situation they are having the value 0 1, then in both of the situation the value of the output will be 1. Next is NOT gate. NOT gate is a logic gate which is having one input and one output, and NOT gate generally performs the reverse operation of the input. That means if the value of the input is 1, then the value of output will be 0, and if the value of output is 0, then the value of input will be 1. Last is exclusive OR gate. Exclusive OR gate is very much similar to the OR gate, except one difference, and that difference is in exclusive OR gate the output voltage is true only when the input voltages or input values are different. That means if two input values are having value 1 or they are having value 0, then the output voltage will be 1 or true. Otherwise the output voltage will be 0, or we can say false. So this was the truth table, the theoretical understanding of the truth table for the 4 logic gates. Next is draw and explain LC oscillator with the application. So here I will explain theoretically what is LC oscillator. LC oscillator is an oscillator in which the inductor capacitor tank circuit is used to provide positive feedback for sustaining the oscillation. And most of the time this LC oscillator is also named as the LC resonant oscillator, LC resonant circuit, or LC tuned circuit. And the application of this LC oscillator, it can be used in a signal processing system and in communication system. Next is discuss the comparators. So as the name clears, comparators are the circuit that can compare two output values or two voltages, that is 1 and 0, to indicate which is larger. Comparators are generally consisted of the specialized high gain differential amplifier. The symbolic representation of comparator and operational amplifier are same, and comparators are used in the CPUs, and they are also used in microcontrollers. Next is draw the block diagram of voltage regulator and explain each block briefly, and the optional question with the fourth question is discuss the fixed voltage regulator. So as you are observing on your screen that the fourth question is all about the voltage regulator. So what is voltage regulator? The function of a voltage regulator is to provide or is to maintain the constant value of the DC voltage, or we can say that voltage regulator has a function. Voltage regulator has the function to provide the constant regulated DC output voltage. Voltage regulators are generally classified in two categories, a fixed voltage regulator and the adjustable voltage regulator. And in the optional question we have asked the question that discuss the fixed voltage regulator. So the function of a fixed voltage regulator is to produce the fixed value of DC voltage. That means in output we will have the fixed output DC voltage, and this output DC voltage can either be positive or it can be negative. For example, the 7-8 series voltage regulator IC can produce positive fixed DC voltage, while 7-9 series voltage regulator ICs can produce negative fixed DC voltages. So this was the discussion on the voltage regulators. Next is write the De Morgan theorem and prove it using truth table, or the optional question with this is give the difference between MOSFET and MESFET. So let's try to answer this question first. So MOSFET and MESFET, as the name clear, MOSFET is metal oxide semiconductor field effect transistor and MESFET is metal semiconductor field effect transistors. In case of MOSFET, there is oxide layer present in between the gate contact and the substrate, while in case of MESFET, the metallic layer is present in between the gate contact and the substrate. In MOSFET, the value of the we can say the cutoff frequencies is less than 1 gigahertz, while in case of MOSFET the cutoff frequencies are greater than 10 gigahertz. In MOSFETs are the main applications of MOSFETs are in ICs, and the main applications of MOSFETs are in microwave devices. So this was the discussion on the short answer type questions. Now let's move on to the long answer type question. The first question is, explain the construction and working of JFET and BJT. So here we have this question is asked about the transistors, junction field effect transistor and bipolar junction transistor. So we have to write the construction of both of them and the working of both of them. While writing the construction, we have to make a proper diagram for explaining their function or their working. Next is, discuss the structure and working of transfer electron devices with parametric and parametric devices. So here this question is for 5 marks, so 2.5 marks will be awarded for the transfer electron devices, while rest of the 2.5 marks are for explaining the parametric devices. Next is, describe the non-volatile NMOS and magnetic memory. So here the question is asked on the type of memory, and non-volatile and NMOS memory. So this question is very simple. Only you have to know what is the non-volatile memory and you have to write about it. Next is, explain the structure and working of encoder and decoder. So here two different classes are asked, the function structure and working of encoder, and similarly the function structure and working of the decoder. Again, it is very simple question. It is easily available in any of the book of digital electronics. Next is, draw the circuit diagram and explain the function of the Wien bridge oscillator. So here the question is asked about the oscillator, and specifically for the Wien bridge oscillator you have to draw the proper circuit diagram and also explain the function of this Wien bridge oscillator. Next is, explain the circuit and working of the astable multivibrator. So specifically this question is very straightforward. In this question it has asked about simply about the circuit and working of the astable multivibrator. Next is, draw circuit diagram and explain the working of series transistor Zener voltage regulator. So you have to study this topic clearly. In this question it is asked about draw circuit diagram and explain. So you have to draw the circuit diagram and along with you have to explain the working of series transistor Zener voltage regulators. Next is, discuss the working and construction of switching regulators. So switching regulator, the function of switching regulator is easily available in any of the book of the digital electronics. Next is, draw and explain circuit diagram of multiplexer or discuss the construction and working of adjustable voltage regulators. So this is the overview of the long answer type question. So this brings us to the end of this lecture, and guys, I have done only the theoretical explanation of this question paper, the diagrams, the related proof of the De Morgan theorem with its truth table, and all such things, diagrams and its thorough notes are available in the Telegram channel of the Autonomous Academy. So please take the advantage of this Telegram channel of the Autonomous Academy, and thank you so much for watching. If you have any comments or any suggestion regarding this video, you can post your queries in the comment section. Thank you so much.